Good evening and a warm welcome to the training program on capacity building of stakeholders for implementation of City Action Plan and third-party audit under the World Bank sponsored training program. In this training program, I would like to talk about air pollution control system that is designed for Green Crematoria. Let me talk about the outline of my presentation. First, I would like to introduce why there is necessity for creating air pollution control system in a cremation ground or in a crematoria. Then what are the various types of sources of combustion in a crematoria? What are the various emission factors for these sources of emission? Then a little analysis of a case study on what are the various gaseous components that are coming out as emissions in the crematoria. Then other emissions, crematoria emissions, again in the case study form. Then the contribution from area sources in a city and the contribution of wood-fired crematoria again in the city. Then little bit about various options for reducing and controlling these emissions and some emission profiles of open-fire crematoria. Then air pollution control in open-fire wood crematoria, that is the NEERI pilot installation. What are the various salient features of that? And what is the environmental impact of funerals as of today worldwide, and what is the thinking of various world leaders on this? Let me introduce the subject of crematoria and its emissions. In our country, as we all know, most of the crematorias are of open fire type. That means open combustion with wood as the source of fuel is being used for cremation of the body. Here, sometimes wood and biomass to the tune of 300 to 500 kgs per body is being utilized. At present, these wood-fired crematorias are not having any air pollution control system in it, which is leading to generation of lots of dust, about to the tune of 5 kgs. Huge toxic acidic gases, PAHs, trace metals, hazardous gases, etc. are emitted from these crematoria. A little study by DPCC on how much area is being covered when one big crematoria, which uses about 100 bodies per day, which cremates about 100 bodies per day, then what is the impact on the ambient air? It has been seen that it deteriorates around 2 kilometers of the area of that crematoria, air quality. In view of this, there is a great need to reduce these emissions from these units through design of suitable air pollution control systems. What are the various sources and what are the various types of crematorias? I have given some pictures over here. This one is the crematoria which is there in the Mokshada type crematoria, where there is a semi-open type of carriage that is being made over here, and a lot of emissions are there again because no pollution control system is involved. It's just a chimney that is being placed over here, and nothing goes inside the chimney in this. Not chimney, basically it's a hood. The second one is again wood-fired crematoria. Huge emissions are coming. These are the pellet type of crematoria, again placed in a semi-open combustion chamber. This is the cow dung based crematorias. This is again that crematoria with semi-open carriages that are there to for combustion. This is the gas-based crematoria, and this is the electricity-based crematoria. So all these crematorias, I have just put some which are there in Delhi, and we can see that about 300 to 500 kgs of wood is being used. Then in Mokshada type, about 150 to 200 kgs of wood is used. Electricity in electric fire crematoria, the time taken is less, like if it is 3 to 5 hours in the wood fire, it is only less than 1 hour, or about 1 hour 10 to 20 minutes in electric fire, in CNG, and even in diesel and other combustion units. So these are all the various combustion units that are being used in crematorias. So how do we estimate the emissions that are coming from these units? For wood burning, for kerosene and diesel burning, for electric burning, and for LPG burning, these are the various emission factors. We can see that for wood burning, it is the PM10 emissions are much more than kerosene, than for electricity and for LPG. Similarly, for other gaseous emissions, wood burning is the highest, followed by kerosene, LPG, and electricity burning. So here you can see that for various types of cremation, how much is the amount of fuel is being used, what is the temperature that is being generated, and what are the various types of gases to the tune of about 5 to 9 kgs of dust and gases are coming out from wood. 6 to 7 kgs of fine dust is coming out from cow dung. And similarly for electricity, CNG, LPG, and diesel fired crematoria. So based on these emission factors, we can estimate the total emissions that are coming out of the crematoria. But if you want to design an air pollution control system, you need to do the gaseous emission identification through various techniques. Now this is a state-of-art Fdir analysis where we have identified like what are the various gaseous emissions that are coming out. This is for an electric crematoria. We can see that lots of sulfurous compounds of organic natures like 1,3-butadiene, then metazylene, then acetaldehyde, then again methyl mercaptan, and so many. These are all identified gaseous components that are coming out from even from the electric crematoria. This is for electric crematoria we have done. Similarly, we have done for wood and other types of crematoria. So this is the photo of electric crematoria. We can see that from the emission factor it is very low, but then these are the various practical issues that I will explain why it is coming in the electric crematoria. Now this is the case study of Nagpur where from 2018 to 22, 2018-19 being base year, and from there onwards we have taken the projection scenario. So this is the wood, briquette, LPG, and diesel, that is the body is burnt under these sources, and PM 2.5 that is emitted because of these sources. The total emissions that are coming out is about 5.7% of PM 2.5 of the total area sources of the city. Now if we see again the total emissions from area sources, so for PM 2.5 and PM 10, so it is 50 tons per year that is coming out from crematoria, and about 72 ton per year of PM 10 that is coming out from crematoria because of this area source activity. Similarly, we can say that about 5.7% of crematoria emissions are contributing towards the total PM 2.5 emissions in the city. So there is a need to reduce these emissions also, and it will be increasing as the population increases, as we construct more and more crematorias, and this is going to increase. Now what are the various options for reducing it? There are various options. We can change the fuel type or change the design of the pyre. So you can use, if you want to have the same pyre, you can use briquettes, biomass, or cow dung cakes, etc. plus APC system. That is very important, because without that you should never use the crematoria without APC system. Or we can use alternate fuels like gas, electricity, LPG, diesel, and this also needs end of pipe treatment of APC system because it provides lot of fumes. Now options of providing APC system directly to the open pyre crematoria is called the Green Crematoria, which NEERI has done the study. Here we have controlled the fumes and emissions coming out directly from the open pyre cremation process without disturbing the process of open pyre. Now how we did it? We did an extensive monitoring and hydraulic studies of the open pyre emission profiles. Now these emission profiles, like what is the amount of CO2 that is coming, because it takes about 3 to 4 hours for this open pyre combustion to complete. So we have taken the analysis of CO2 percentage, SO2 and NOx percentage, dust, total dust, PM10, 2.5 and PM1, all these percentages in this 4 to 5 hours of combustion. This is through extensive monitoring. This I am just showing an indicator graph. Similar studies have been done to see how the pyre fumes height changes, how the pyre fume temperature changes, the velocity and the fume composition in terms of CO, changes all these 15 minutes to 3 to 4 hours of the emission profiles. Having done this profiling study, we understand like what is the quantum of gas and what is the temperature and velocity and composition of flue gas that we need to handle for 4 to 5 hours once the cremation starts. Based on that, we have studied once we have studied how much is the gas to be handled, we have designed the handling system in terms of the fume hoppers and the dust collect and the gas collecting system and the wet scrubbing and the demister systems, followed by how much is the capacity of the blower that needs suction of this much amount of gas, and what should be the height of this chimney for safe disposal of the gas. So having done this, we have installed this system in this is that total fumes that are coming out from the combustion of a body, and this is directly going in the hood system, which is connected to these are the four open fire crematoria. We have 4 individual hoods which is connected to the common duct. This duct goes inside the wet scrubber. This is that wet scrubber wherein it is coming from inside, so it goes in that wet scrubber, it gets scrubbed out, all the dust and gases get reduced over here. This is that cyclonic scrubber, which again reduces the dust and the gases that are coming out from this crematoria. The moisture laden gas then goes to the demister, which is there here. This is that demister, and from this demister all the excess moisture and water vapor and water that is there gets taken up. All this scrub liquid and this excess moisture is taken up in a ETP system there, which treats this slurry, and then treated water is again taken back in the tank of the wet scrubber. Now the gaseous emissions that are treated in this is being released through the chimney. So here the treatment that is given is wet scrubber and demister, followed by this can be a reactive wet scrubber also, where we can use various chemicals to reduce the organic emissions and the inorganic emissions. So this is that study that we have done for monitoring our inlet and outlet of our system, and this is that chimney through which we can see that not much emissions are coming out and through this chimney. So this is that inauguration of that Green Crematoria. This is that Nigam Bodh Ghat 4 pyres where we have done, and this is the Honorable Minister's presence. It has been inaugurated. Now, what are the salient features of this crematoria? It reduces the total dust particulates to the tune of about 65%, fine dust to about 60%, NOx to 68 to 70%, and acidic gases like SO2 more than 90%, other gases like carbon monoxide, CO2 and THC to more than 80%. The waste generated, that is effluent that goes to drain, is about 10 liters per week as per the CPCB discharge limit. So this is treated as per the CPCB discharge limit and can be either reused or it can be discharged. The cost is around 30 lakhs for 4 pyres, and the operating cost of 10 hours daily operation is rupees 10,000 per month. This is for electricity and water for the system. The performance, as we see, the same thing as TSP, we can have more than 60 to 65%. For other gases and organic gases also, it is more than 60%. So this is that outlet emissions from Green Crematoria complies with the concentration based general standards of CPCB. Now this is that slurry or the sludge this is the sludge that is generated when this is that slurry that is coming out from the after the scrubber. So this otherwise this much amount of dust was going in the atmosphere, which is otherwise taken up by the scrubber. So what again the salient features are: it is high volume, high efficiency and high throughput scrubber, which is low cost, easy to operate and maintain, low operating cost, recycling of liquid for 10 to 15 days with minimum makeup water, easy for cleanup and solid waste collection discharge, maintaining traditional ethnic culture and pollution control within its framework. It can be used for a social cause. safe disposal of COVID body combustion, and improvement in nearby air pollution and general local ambient air quality. So these are all the various benefits that we can get. One study from the US for environmental impacts of funeral, it states that the burial, the shadow price in dollars, in the shadow price in pounds is more for burial, and it seems to be less in Indian type of cremation. So we should encourage such things, but we should have very good air pollution control. In Western countries, like this is the Chinese cremation unit, which is absolutely smokeless. Similarly, we can have, these are the Australian furnaces for cremation, which are zero emission cremations. Thank you, and any questions please.